Thank you, thank you. So, hello everyone, we are very happy to be here. Today we're gonna explore together some new ways of doing interaction design. At the core of this, there's obviously Vision OS by Apple. But this talk won't be much about the technology. This talk wants to be about how developers and designers can collaborate together to create seamless, intuitive, and truly design human-centered spatial experiences. Before we dive in, we would like to introduce ourselves first. I am Giovanni Monaco, a creative coder. I bring art to life using code, and I love to explore the intersection of design and technology.
Hello everyone, I'm Emanuele, product designer, trying to create intuitive user experience across the entire Apple ecosystem and of course Vision OS.
We both love, obviously, Vision OS, the way it's changing the way we think, we design, and we interact with the digital content. We both work at Imaginary Institute, which is a design and tech consultancy that brings imagination and technology together for creating solutions for our private clients or public organizations. And one of our key initiatives is we are two senior mentors at the Apple Developer Academy in Naples, Italy, where we co-create and co-facilitate the learning experience for our students. Not only we help them building great apps, but we also help them creating a product mindset and collaboration skills. And you probably know us for Create with Swift, where we write tutorials, articles, and this is for every developer or developer wannabe in the Apple ecosystem. But let's focus on what we're going to talk about. We're going to have a very brief introduction, and then we're going to jump in designing for spatial computing, on how we can translate 2D into 3D, but most importantly, how we can design 3D experiences that are exclusive to Vision OS. And then we're going to move to hand gestures and eye interaction, because they are the main two ways our user can really enjoy the digital content. And if we want to design something that is truly human-centered, we should take care of these two. So let's start this. First of all, when we start designing for spatial computing, we should first understand where our experience fits into the reality spectrum. Vision OS primarily works into the MR field, but it can easily slide in the spectrum as much as we want. And we are kind of used to this with extended reality that in time has blurred every line that somehow divides AR, MR, and VR, creating that magic in our experiences. But when we start designing for spatial computing, obviously we have to look at the future, but there's so much we can take from the past, from fields that have studied for centuries how humans interact with space. I'm talking about architecture, I'm talking about urbanism, I'm talking about interior design. Let's see how this can really help us developers in doing what we want to do. Architecture can teach us scale, structure, materiality. Architects can really help us in understanding how we can create virtual spaces that feels proportionate and realistic and which our user can understand at a glance. Or urbanism can teach us movement, flow, social interaction, proximity. And this is particularly interesting if we are creating collaborative experiences in Vision OS. Or, last but not least, interior designers can really tell us where to place our virtual objects, how light should be, or which color we should choose if we want to, our user to have that exact emotion we are looking for. So, a lot to take from the past, but as well, spatial computing do not have any physical constraints. Walls can move, rooms can get bigger and smaller in seconds, and finally, gravity do not exist. So we can really set our imagination free, as have we seen in the morning as well. But before we really do that, we want to cover with you some basic of designing for spatial computing.
So, when we think about Vision OS, of course, we have new challenges to face, right? But as we were introduced also this morning, Vision OS is part of a greater system that Apple built along the years. We have macOS, iPadOS, so on and so forth, each one built for a specific purpose, a specific reason. but at the same time, they are part of the same family. So they share together design principles, as well as design philosophy, development framework like Swift UI. So we, of course, can recall these experiences also in Vision OS. Starting from native application is a great way to analyze structures and understand how we can switch from two-dimensional experiences to 3D environments. If we think about the iOS version of the app, we can see that the main interface is occupied by the content, right? So in this case, music, playlist, artist. We can easily switch between different sections of the app thanks to the sidebar at the leading side. And of course, I can control my music thanks to the media controller at the bottom. If we think about the same app for iOS, of course, the structure and the components are the same. So I have the main content. I have a way to control my music thanks to the media controller. And I have a tab bar to easily navigate between different sections of the app. So what we see is that the structure is the same, but the layout is different. Because, of course, the iPhone is primarily used in a vertical landscape, so the navigation and the tab bar is easily to reach with our tab at the bottom. If we think about the same experience in Vision OS as we saw this morning, so we have, first of all, our beloved glass material. On top of it, we have the main content that is made of, again, of playlists, artists, and songs. At the leading side, we have a way to navigate inside our app that is through the sidebar and the tab bar that can coexist in Vision OS. And I can control my music with a media controller at the bottom. This time in a brand new component that is called Ornament that probably you already explored in Vision OS. All of this is possible thanks to 3 ways of presenting content, so through windows, volumes, and spaces. So what we explored until now was a windowed experience, and the same is in this example. That is probably the most familiar kind of experience that you are used to, also in other operative systems like macOS, but this time everything is happening in our real environment. If you want to create more interactivity with the object and volumes, then this is the right way to present your content. And last but not least, of course, we can have spaces. That is the most immersive way of engaging our user. What we are seeing, of course, is you need to carefully plan how you want your experience to be. Usually, you want to start experiences in shared space, so through windows and volumes. Shared space means multiple apps running at the same time, again, as it happens on your Mac. While if I want to immerse more and I want my user to be focused on specific content, probably I want to create a full space or full immersive experience. Also, spaces has 3 different levels of immersion. One is mixed, that is basically, again, interact with the digital content while keep seeing my real surroundings, my real environment. I can decide to be more immersed with the progressive space, meaning users can control how much they want to be immersed inside your experience thanks to the digital crown. And last, full experience. That, of course, is the most immersive way of delivering your app. And the only thing that is missing after that we have overviewed the main tools that are useful to create Vision OS experiences is imagination. So imagination has a key role now when creating spatial computing experience, because as Giovanni presented before with the matrix example, walls can move, objects can float because probably they are not affected anymore by gravity in our experience, or our control can and windows can be literally placed everywhere in our environment. But having this freedom means that we can leverage, again, our imagination in 4 different ways. So if we think about mimesis, mimesis is a Greek word meaning copy, simulating. In fact, mimesis is when we try to bring real-world examples, real-world stuff that happens daily in our life, also in this case, digital experiences. If we think about window-ed experiences, these are mimicking our reality, because actually we are used to it, again, thanks to macOS and other operative systems. If we want to go a bit further, then we can go for hyper imagination. And it's when I can dissect specific element, like in this example, like an anatomical part of our body. So when we do something that is not possible in reality, or another good example is the Jig Space app that we saw this morning. We can even go further with the liminal object. That is basically when we want to play with the user perception. We want to go further than space and time traditional convention and creating an experience that is surreal. And last, Fantasia. Fantasia is the greatest level of imagination where you are not linked anymore to reality and you can literally create the experience that you want. A great example is Thrasher that we saw literally the talk before. So this is the entire tool palette, toolkit that you may use for creating your experiences. But now it's important also to focus on how user will interact with our experience.
Okay, talking about how to interact. Let's start with the hand gestures. I think you know what we mean by hand gesture, the fact that we can really control the digital content using our hands. This happens usually when we are seated comfortably on the sofa and we are looking at photos while moving our hands in air. But we have two ways of really interacting with the digital content. One is the indirect gesture, which is very common. Again, it's used when I'm scrolling, I'm selecting a menu, and that's also what it's suggested. Don't go extra if you don't really need it. Or you can have direct gesture. The example we have is Super Fruit Ninja, which is a game where the user can cut fruit using their hands like they were katanas. That's another kind of experience we can go for. But let's focus on indirect gesture for a second. I want to tell you that this, we have to be very careful when we design indirect gesture. That's because they work no matter where the content is usually placed. We can, as designers, we should decide where the content is placed, taking something into account. First, if we move objects more than 3.5 meters from the user, we are in the public area. Public area, it's what's happening right now. You're very far from me, the conversation is one way, and I'm not having any physical contact with you. Or I can decide to have the content in the social area. It's where I usually meet people, I start conversation, body use, it's very limited. Probably I will handshake, not more than that. Or I can use intimate and personal, like me and Emanuele right now. That's used for family, acquaintances, again, very personal. I can even hug the person in that space. And there's one area more that it's not visible there, which we call forbidden area, which is very close to the eyes of the user. You want to avoid putting content there, or you can create a very uncomfortable experience or even panic in the user. So be careful of that. Going back to indirect gestures, again, no matter where the content is placed, I can interact with it. And to give you some examples, that is something I can achieve using Windows and SwiftUI only. During the talk, we're gonna use this app called Interactions Playground as an example. Don't worry, we're gonna share the entire Xcode project with you if you wanna dive deep into the code and have some examples. I won't be commenting the code too much. I will just go to some highlights of it. In the app, you're gonna find the six main gestures that are native to visionOS. And for each one of them, we have created 6 small playgrounds to test them out. I want to stop for a second on pinch and hold. We talked, I said in the beginning of the talk how important it is for designers and developers really communicate and collaborate together. And this is one great example, because this gesture, it's called pinch and hold in the human interface guidelines as suggested by Apple, but developers may refer to it as a long tap gesture. That's because it's coming obviously from all times of iOS and iPadOS. Or Some suggestion for the designers of VisionOS take always into account that zoom and rotation this time on VisionOS happens with 2 hands rather than 1 only, as it used to be in iOS. Moving to direct gestures, which that means I can interact with the content, let me say touching it. That's a great news, because if I use SwiftUI native gestures, indirect gestures, that translate automatically into direct gesture. In this case, I can reach that pink rectangle and drag it around as I want. And this is also highly suggested by Apple, because this is everywhere, basically, in the system. Some examples are Safari, where I can scroll the digital content in a window, like I had the big iPad in front of my eyes, or the keyboard, that by the way, it's a great example of direct gestures, because I have many feedback that I get from that, where when my fingers are very close to the keys, the buttons highlight a little bit, and I have some audio cues telling me that I'm really pressing those buttons. But let's be honest, and we saw it with Blackbox this morning. Great experiences are the ones that are really immersive, like we are seeing on screen, and how to get there, how we can really get there. Let's start with volumes, and you're gonna probably need Reality Kit for this. Again, in the app we're gonna provide, there are some examples for this as well. You're gonna find, again, in the app, 6 different playgrounds, this time with volumes and Reality Kit. I'm gonna stop for the talk just on the tap gesture, just to keep the talk simple enough. The experience has been translated into a 3D experience this time. I have 9 squares that I can interact with. If I do an indirect or direct gestures, they will color of pink. How can we get something like this? Obviously, we're gonna need Reality Kit, but I'm gonna build an entity that conforms to has model and has collision. And most important part of the code is that I'm gonna add to that entity a physical body, an input target, and an over effect component, as well as a function that handles the fact that I'm tapping that entity so that the color can change. This entity will be then used in a view into specifically the content of the reality view. And I'm gonna add a gesture modifier with the well-famous tap gesture that connects that gesture to the function that I had in the entity before. If we really want to go extra and probably wanna create something like Blackbox, then I need to go full immersion. Then I need to use a space. I definitely need to use Reality Kit, and most probably you're gonna need ARKit to start the hand tracking. In the app again, you're gonna find a new experience that you can have a look at. Something like this, where I'm live tracking my hands. I have 2 pink dots on the index of my hands, and if I pinch with my right hand, a pink sphere will appear in the index of the left hand. So what happens? The sphere knows that there's a table in front of me, so just stops there, and I can even interact with my hand, playing with the sphere or kicking that out. How can I create something like this? Again, I'm gonna need, for sure, ARKit and Reality Kit. What happens here, the code gets a little bit more complex, but I'm gonna stop just on the view model of it. What I'm gonna need is definitely an ARKit session for starting the hand tracking, as well as an hand tracking provider and scene reconstruction that really tells my device what's the environment around me, so that the sphere knows I have a table in front of me. Enough for code. If I go back to designers, I talked about how much important is for designers with this technology to have a look at the past. We talked about architecture, we talked about interior design, but designers should probably start also having a look at anatomy as well, because now being a designer means also being familiar with all the possible anchor points every hand has, thanks to VisionOS, which are 21 and are all the possible joints of the hand, because I can use them as an anchor for my digital content. As well, designers should be probably the one deciding if developers should use an asynchronous anchors or predictive anchors. What's the difference here? Asynchronous means I still have updates at a very high rate, which is now display rate, by the way. But the content could be a little bit laggish, but the precision will be very good. Or I can go for a predictive hand model where I have some machine learning involved. The content will be very smooth this time, but the object could be in the wrong place for some time. I think we have explored enough for hands. Let's move to eye interactions.
So we know that our eyes become our new pointer in VisionOS, right? Like the cursor is on our Mac experiences. The cool thing is that in this operative system, all the elements are reacting to our gaze. So for example, the tab bar showing additional information that is also great for accessibility reason. Or for example, showing some tips when I long focus on a button, telling me what the button is about. And my personal favorite, that is triggering actions like speak to search. So I long focus on the microphone and I activate voice research. All of this needs us to take into consideration what is the field of view, how it works, so we need to study a bit more our human body. The field of view is the area I see in front of my eyes without moving my head, right? And we saw with Giovanni that I can decide which kind of experience I want to create, if it's a personal experience, a social experience, so on and so forth. But understanding field of view is not all about the distance in which I put my content or where I put my object. But it's also understanding how our eyes and most importantly, our mind process all the information in the real environment and in this case also in the digital environment. So we are Italians and of course we need to bring our Renaissance moment, otherwise we cannot consider ourselves truly Italians. And this is a great masterpiece from Masaccio, one of the greatest artists during that period. And why this is important is because this artist can let us understand better how perspective works. So they were revolutionary because they switched from two-dimensional paintings, because usually all the paintings were like a golden background and flat humans, saints to be more specific, and now they brought a completely new concept of three-dimensionality, illusion of depth, because everything was built with the technique of the central perspective with the single vanishing point, meaning that users had the illusion to look at a three-dimensional painting, like there was a real depth inside the masterpiece, right? And as well as this revolution happened during that period, thanks to arts and painters, the same is happening now in VisionOS. So we need to, in technology environments, okay? So we need to consider again how we are placing the content. If I'm putting, probably I will put all the information that I think are fundamental and inside 30 degrees, or for example, secondary actions like the tab bar that we saw before, or ornaments inside 60 degrees, and everything else that go outside of this area probably should be put inside 90 degrees or outside. As an example, I open an object, I open a volume. Probably this won't appear in front of my face, but more on the side of my field of view. We could talk for hours about how the field of view works, but first, we don't want to annoy you with a lot of content and anatomical session, let's say. But at the end of this talk, as well, together with the interactive playground, we are giving you a design resource that is called Spatial Design Canvas that will help you out in case you want to plan and decide a spatial computing experience. Something that we want to highlight is also that probably we think that three-dimensionality is something new, but we as designers and developers always handled with three-dimensionality, with the different layers. The cool thing is that while before this is we only had this awareness of the three-dimensionality. Now in Vision OS, also users have the perception, the illusion of depth. So this becomes tangible for everyone, actually, not only developers. So we have a lot of visual feedback, but there is something missing, that is the tactile feedback, right? We are not touching anymore something like we did until now. We are not touching anymore the screens of our iPhone or the trackpad of our Mac. So we need to convey other ways for our users to understand that they are performing an action, that they are looking at something. And that's why visual feedback and audio cues become fundamental. Back to the interactions playgrounds that we explored before, let's suppose that I want to create a simple grid of rectangles that we saw together with Giovanni. If I start with the basic implementation, probably this will be your code. So I have the grid and I have the rectangles. But there is a lot more that we can do. First of all, we can use an over effect modifier so that our user will immediately see this white halo while we are going with our eyes to select a specific object. We can also have an help modifier that is showing a label, a description, telling your user what these buttons or actions will trigger is about. And again, this is fundamental also for accessibility reason. This is not new in Vision OS. We had this help modifier also in macOS when we go in hover with our mouse on a specific element and we have this pop-up telling us additional description. Last, we can also implement a scale effect. So like this pop-up animation when I pinch on a specific element. All these three elements will provide additional feedback to our user. We say, yes, you are selecting this object and will be clear for everyone. The cool thing is that all of this is also can be easily implemented also with the Reality Kit when we work with the volumes and using indirect gestures, so when I'm not directly touching the object. But even cooler is that we can have same over effect with the direct gestures, but as you may perceive, this time is not controlled by my eyes, but it's while I'm hovering with my finger, I have this white halo telling me where I'm what I'm selecting inside the experience. And this is possible thanks to the over effect component that can only be applied if we also have physics, body, and input target components. Last suggestion is how you place the content and the shapes that you use. So try always to use circles, rounded shapes, rounded rectangles, because there are multiple reasons why you should do that. First of all, our eyes tend to be more stressed if we use sharp edges, while we'll be less stressed if we use circular shapes, because our attention goes at the middle of the button, like in this example. And remember that we are constantly wearing screens in front of our eyes, so it's important to create a comfortable experience. And of course, we need to be aware of the target area that should be at minimum 60 points, but all this information, of course, are on the Apple Human Interface Guidelines and the Apple documentation. And of course, we should have a good distance between elements, so I can avoid that my user have frustration and issues in understanding which buttons they are tapping. And if you respect these distances, this will be possible regardless of the distance where you are placing the window inside your experience. So I think that's enough content for now.
So that was enough. Let's have a quick recap of all the things we have shared. First, we have started with a look to the past and all the things that we can learn from fields that have studied for centuries, like architecture, interior design, before we really create and design the experiences of today and tomorrow, and we unlock our four typologies of imagination. Then we have explored gestures, direct and indirect. We have explored eye interactions and how they're possible, and the field of view, and how all of this it's possible using SwiftUI, Reality Kit, and ARKit. That said, so we told you we write on Create with Swift, and we have also a special section which is called Make It Spatial, with all articles, tutorials, that are specific to visionOS. And you can have all of this in your inbox every week if you want. Just scanning the QR code that is on screen. We're going to add you to the mailing list, sending you all of it. But also, we promised some resource for you. First one is the spatial design canvas. Goes into much detail of how to design a brand new spatial experience. But we also promised you the app Interaction Playground Xcode project. So if you want to have a deeper look into it, you can download all of this in our Gumroad page by Imaginary Institute. You're going to find also something else in the next days, and we try to keep this as updated as possible.
So while you are scanning the code, I would like to add that we have stickers, so come and find us to have them, okay?
Thank you very much for being with us, and we cannot wait to see what you'll create with Swift.